Assalamu alaikum warahmatullahi wabarakatuh, everyone. Today, inshallah, we will solve problem 24 from chapter 2. And the question says, determine the solution xt of the differential equation 2x double dot plus 2x dot plus x equal 1. And it gives us an initial conditions with x at 0 equal 0 and x dot at 0 equal 1. First, we will start with converting this equation to S domain. So to convert from time domain to x domain, we will use Laplace transformation, and the conversion of x double dot will be s squared x s minus x minus sx at 0 minus x dot at 0. And for x dot, it will be s xs minus x at 0. For x, it will be just xs. And for 1 or any constant, either 1, 2, 3, 4 billion, it is just the constant over s. In that case, it will be 1 over s. Now, before plugging this transformation back to our original equation, we need to first simplify it using our initial conditions. Okay, so this will go to 0 as indicated in the initial condition, and this will go to 2. This also will go to 0. Now we will plug these back to our original equation. So we'll have 2 multiplied by 2 s square xs minus 2. No, sorry, yeah, it will be like this. Okay, minus or plus, where is it, plus 2 2 s xs plus xs equal 1 over s. Okay, so let us simplify this more. It will be s squared xs minus 4 plus 2s x plus xs equal 1 over s. Okay, now we will take xs as a common factor. So taking xs as a common factor, we will lift up with 2s square plus 2s plus 1, and we will take minus 4 to the other side, and we will lift up with 4 plus 1 over s. Now we will take this and divide it, or divide it over this term, these two terms. So we will lift up with xs equal 4 over 2s squared plus 2s plus 1 plus 1 over s multiplied by 2s squared plus 2s plus 1. Okay, now to get x, the solution x at t, okay, we need to transfer this back using Laplace inverse uh, to originally the time domain. But the problem is we don't have, as you can see here from the table, we don't have any time or any terms that is similar to what we got here. So we need to do some modification in order to get our xt. Okay, so one of these modification, or let us take it first term by term. For this term, we need just a simple modification, which is completing the square. So what we will get, or what we will do, is taking this term plus 2s plus 1. First, taking 2 as a common factor, so we will lift up with 2 s square plus s plus half. Then we'll use completing the square by taking uh, this the coefficient of s and divide it by 2 and then square it. Okay, and add it to our equation and subtract it from our equation to not change anything in the equation. Okay, so it will be like this, plus 0.25 because it's half squared. Okay, plus or also minus 0.25. So we're adding and subtracting, and plus 0.5. Okay, so this will be, sorry, this will be s plus 0.5 all squared plus 0.25. We'll come back later to this term. Now let us go uh, to our second term, okay, which is this one. So let me copy it. Let me just copy it. Okay, okay, and we will have here s. Okay, so as I mentioned, first we will take 2 as a common factor. Okay, we'll take 2 as a common factor, and here we'll left up with uh, 2 0.5, and here we'll left up with 0.5. Okay, now what we need to do is a further step, which is using the undeterminate method, so that it will be 1 or a over s plus bs plus c over s square plus s plus 0.5. We will do the completing the square later. Okay, so the undeterminate method, it will be 0.5 equal a, and multiplying this factor by this, so s square plus s plus 0.5, and this factor will be plus bs plus c multiplied by this one, which is s. Okay, now to this is the undetermined method. We'll put these out. Sorry, let's make them like this, and we'll have this 0, which is just a constant. Okay, so okay, so for s square, what are the coefficients for s square in the right hand side? We have a, okay, and we have b, which is bs multiplied by s square, and we'll put b. For the left hand side, we don't have any s square here, so we'll say it will equal to 0. For s, we have a as well, and here we'll have c. Okay, so plus c, and also in the left hand side we don't have any coefficient of s, so we'll just put 0. Now for the constant, what are the constant that we have? We have half a. Okay, so we'll have half a, and we don't have anything here, and in the left hand side we have half, so a here will equal to 1, and c here will equal to minus 1, b here will equal as well to minus 1. Okay, this is the indeterminate method. So going back to our equation and substituting these values, we'll have 1 over s minus s plus 1 over, I took the minus as a common factor. Okay, uh, s square plus s plus 0.5. Okay, okay, now we need to do, as I mentioned before, the completing the square, because we don't have any type of form in our Laplace table that is the same as this one. So we convert this term, we put our 1 over s, and we convert this term to uh, what we did before, which is completing the square. So this is 0.5 square plus 0.25, right? 0.25, and we put back our previous term, which is 2 over uh, s plus 0.5 all square plus 0.25. Let me just check if it's yes, it is. Okay, now we'll use our Laplace. Oh no, just give me a second. Okay, sorry for that. Okay, we got our table back. Okay, This is our table now. So as you can see, there is some sort of like similarities in some fact, some fractions, which is here and where as well and here, right? So, but we need to first like have similar numbers as a here and here, because here we have one only and here we have half, so we need to have half here. So what we are going to do is making it 0 0.5 plus 0 0.5 for this one, and for this one we need it to be 0 0.25. So, or sorry, as you can see here, b should be uh, the square root of b square. So this 2 need to be 0 0.5. So what we are going to do is make it 4 multiplied by 0 0.5, which is basically equal to 2, right? Okay, now using our Laplace, we know this will be 1. This will be 1, and sorry, this will be yeah, this will be like with s plus 0 0.5 over s plus 0 0.5 square plus 0 0.25 plus the same 0 0.5, because it's addition, right? So I can take this over this, and I can take this also over this. Okay, so this is s plus 0 0.5 square plus 0 0.25. Okay, and for this one we just will make it like this, plus multiply by 4 0 0.5, or let me just make this back to 1. Okay, so this is plus 0 0.5 all square plus 0 0.25. Now we are ready to convert these fractions back to the time domain, right? So this will equal to 1 minus, from here we have, yeah, we have this one. Okay, so if you have like here, if you are confused, like I have minus a here, which is equal to 0 0.5. So your a that you are going to put it here. So as I mentioned before, a will be, or if you are confused that I have here minus a and I have above a positive number, what I'm going to do, just put here like this one like this, and here you have your a. Okay, just, or in simple words, just like multiply by minus sign. Okay, so here we have e minus 0 0.5 minus 0 0.5 t, and cosine, cosine, what is our b here? Our b is 0 0.5, which is the square root of this part, t, right? Okay, this is our first term. For our second term, it's already, it is this one as well. uh is it this one, or no, not this one, sorry, it is this one. Yeah, it is this one. So it will be e minus 0 0.5 t sine 0 0.5 t. Okay, and here we'll have 4 multiplied by the same e minus 0 0.5 t, and we will have here sine 0 0.5 t, right? Am I right? Yes. Yeah. Okay, now this is basically copy, let me just put it here. Yeah, so this is basically our x of t. Okay, thank you guys and good luck.